You say, why does this matter? Well, because I'm out here telling you this is a technology that you can base major aspects of what you're trying to defend upon. If I was out here saying, trust me personally, you know what, I'm some guy who's up to some interesting stuff, but I'm still some guy. It matters that there is a healthy range of suppliers. This technology has some legs. Now, what I am here to do is tell you not simply what other people are doing, but tell you where this technology is going on the 6 to 18-month time scale. So first off, let's begin by talking about DNSSEC itself. You know, it's not that complicated. You ask a question, you get an answer. Or you ask a question, you get a referral. So you go to Alice and say, what's Jenny's number? Says, ask Travis. You go to Travis, say, what's Jenny's number? Says, ask Charlie. Go to Charlie, ask Jenny's number, 876-5309. It's really not that bad. So here's what DNSSEC does. You ready for it? It adds signatures. So, Alice, what's Jenny's number? Ask Travis. Trademark. Travis, what's Jenny's number? Ask Charlie. Trademark. And you might say, no, it can't be that simple. It can't just be a little extra goo at the end. I mean, come on. Is that it? No, I mean, that's really mostly it. There's a little bit of stuff. Referrals now, instead of just telling you where to go, give you a new key, a new way of understanding, okay, go over to ask this guy and here's who he is. So before, you were just told where Travis was. Oh, go ask Travis. He's down by the water fountain. Now you're told, here's how you recognize him. Oh, he's the skinny white guy with the dreadlocks, who's now the chief hardware officer of Recursion Ventures. Welcome aboard, Travis. Are you in the room? Howdy, neighbor. Now, it's not quite so simple. Computers can make stronger identifiers than humans do. Everyone always says, how do I explain public key cryptography? You know what? It's really easy for me to recognize my grandma's face. I'm not so good at looking like her. Bam, you now understand public key cryptography. So, there is some magic here and there. Saying Jenny has no number has some magic. This is what's called NSEC and NSEC 3. And time is involved. So, referrals will only last a certain amount of time and so on. And keys can lead to other keys as well. Some of the magic is optional. A lot more than you'd think. When you hear DNSSEC is complicated, it's because someone thinks the magic's not optional. Now, all of the magic can be implemented in an easily deployable manner. The easiest is have someone else do it. Go to a vendor, get a magic box, go to a managed service provider. However, I don't want anyone thinking you have to do this because the technology is a mess, because it's not. So here's what we're going to do. We are going to taunt the demo gods and we are going to deploy DNSSEC from scratch on stage. Let's do this thing. All right. Man, I've heard this takes like 100 hours. There's no way I have time for that. Luckily, I don't actually need that sort of time. So here's what we're going to do, all right? I don't think anyone is going to be able to read that. So we're going to have to log back in here. See, this is the problem with live demos. Let's do this. This is the other reason why I can't do all the demos live, because it would eat up all of my time. But I think this one is, if there's one thing that people need to see, that this is just not that big of a deal. By the way, does anyone here know about Cygwin for Windows? It basically gives you a Unix shell on your Windows machine. Eventually. Damn, that's not good. Can I get SSH, please? Maybe. Balls. That one work? Okay, the little one worked. I apologize. You're just going to have to believe me for some of this stuff, okay? So here's what we're going to do. We have a standard server here. It's got a couple of zones in it, like doctorsoffice.org and somecustomer.org and navy-dot.mil.org. And, I think this server should have DNSSEC. Let's see what that's going to take. So, First thing we have to do is we're going to go ahead and, so step 1, make the name server listen on a different port. Named.com. I think that's options. All right, let's go ahead and make that listen on port 5003. That's step 1. We have to go ahead and restart the name server. All right, now step 2. We have to run Phreebird, which is a totally new DNSX server that we've been developing for a while. So now we've run Phreebird. Step 3. There is no step 3. We actually just deployed DNSSEC. So look up at localhost with the DNSSEC flags. I don't know, www.hospitallink.org. Oh, hey, there's actually a whole bunch of trademark extra goo. Man, that really didn't take long, but that couldn't really have worked. I mean, are there DNS keys? Oops, actually, you have to look it up on the main. Yeah, there's a DNS key. There's even a DS key. Huh, this ain't so bad, is it? Now, I know what you're saying. Don't you need to go ahead and talk to GoDaddy? Okay, that I'm not going to do live. Okay, so what do? You go to GoDaddy, put in your zone, say you want to manage DNSSEC, you paste in some numbers, which you got by just saying, look up, in this case, remotesupport.org, look up the DS, you get that value. You say, yep, why don't you push that? You wait 30 seconds, and it's deployed. And there it is, and it worked. And you just deployed DNSSEC in 2 minutes. Now you might be wondering, and by the way, that's an end-to-end DNSSEC resolution that you're seeing right there. So why this works? Why was this so easy? I thought DNSSEC was supposed to be a horrible pain in the butt to deploy. Well, DNSSEC was designed to allow key in a vault approach to security. What that means is every once in a while, you take the magic super key out of the box, and then you update your zone in some great ceremony. Now, why was this model something that the DNSSEC people had to implement? 2 reasons. First, okay, guys, they've been working on DNSSEC for a long time, which means, 18 years ago, 15 years ago, 10 years ago, CPUs weren't very fast. If you wanted to be able to do a high processor task, you had to have a lot of CPU available. And so you didn't want to do this, oh my God, I got a DNS request, let me go ahead and spend 100% of my CPU for 5 seconds. You had to do it all in advance. So that was the first reason. And the second reason is that DNSSEC needs to support systems that operate at scale. When you wonder why VeriSign hasn't signed .com yet, guys, .com is enormous. And they've really needed to push a lot of this stuff to its limits. So that's kind of why DNSSEC needs to go ahead and have offline signing and a lot of the complexity that you might have heard of. But the thing is, offline signings were really expensive, just in terms of the operational contortions that one has to go through. Now, there's been a lot of work to automate this stuff with cron jobs and so on, but it remains complex. Phreebird is an online key signer. It doesn't know anything about some larger zone list of names, big pre-computational phases. A request comes in, it's looked at, says, you want the signature for that name? Well, let me go see what the value is for it. Okay, here you go. I'll sign it on demand. Now, we did not invent online key signing. SSL, SSH, IPsec, most, in fact, network protocols have their cryptographic keys online just waiting to sign stuff. There's a bit of religion here, but I don't care about religion. I care about what operationally works. And in most protocols, what operationally works is having the key online, and if you don't want someone to extract it, you put it in a really good box called a hardware security monitor, or HSM. Now, there's been quiet but very visible support for online signing dotted throughout the RFCs. Thank you, Ben Laurie. We're not the only implementation that is doing online signing, which we've found is much easier to deploy. Bert Hubert's Power DNSSEC does it as well, but we do have one kind of neat thing. Yeah, we're a bump in the wire. We're a proxy. You want to have your entire DNSSEC framework running, DNS framework running just like it always has, but oh yeah, throw some DNSSEC in front of it while you're at it. No problem. There's nothing operations likes better than minimal disruption. There's no configuration. You didn't see me provide some big list of arguments to Phreebird. I was just like, hey, go proxy that thing listening on 50053. That'll be great, thanks. Our present implementation is a UDP port forwarder. So it goes ahead and just uses a full-on application layer forwarding. We're actually building a mode using what's called the Linux mangle table. And this will allow the back-end name server to still see the original IP addresses. However, its responses will just magically inherit signatures. Now, one of the things I said early on was what we did to fix the DNS bug 2 years ago was a Band-Aid. Someday, DNSSEC is going to have to be as easy to deploy as that patch was. Now, this isn't quite as easy to deploy, but man, it's pretty close. Phreebird's fast. This is not because of me. This is because the Linux kernel developers, libevent, and especially Niels Provost, are badasses. Check this out. We were talking earlier with some guys at VeriSign. Not so long ago, their entire operation hosted 60,000 queries per second in 400 lines of code on now modern hardware. A libevent-based DNS server a single libevent-based server will handle the entire load that VeriSign as a company used to have to deal with. That, my friends, is pretty crazy. Now, we're not going to be at full 60,000 queries per second because we have a back end to speak to and so on. But without any tweaking, Phreebird as a proxy does not seem like it's taking a particular amount of load. It seems to be a couple orders of magnitude fast, at least an order of magnitude faster than the basic servers we're dealing with now. Phreebird caches. The reason why it is, so what we do is this. Anytime a request comes to us, we have no idea what the response is going to be. Because there's no reason when you ask the same name server the same thing twice, it has to give you the same answer. So we always pass something to the backend. Backend sends something back to us. We're like, hey, wait, have I already signed this answer? And if so, we don't go ahead and re-sign because that requires computation. We pull it out of the cache. But the actual answer, the actual content, is always under the control of the backend. They might say, well, Dan, why is that a big deal? Well, because you may not have noticed, but most of the really big sites nowadays use content delivery networks and dynamic DNS determination. If DNSSEC meant you had to completely re-architect the way your high-performance site used the internet, you won't deploy DNSSEC. And you know what? I want people to be able to deploy DNSSEC. So that is why we took this particular path. I don't care what you're hosting, we'll sign it. So, it's open. Why is it open? Because let me tell you, you just re-implemented anyway. You might as well use our code. We should have the code out today. We don't because I've been working on mad crazy demo stuff. If you send an email to info@recursion.com, we'll send you a preview copy complete with horrifying remotely exploitable flaws. The actual code should be out in a few weeks, complete, of course, with Justin Ferguson's pen test report. But remember, what we're talking about here is on the 6 to 18 month timeline. This is where things are going, not where things are necessarily at. Now, Phreebird does a lot of things I don't have time to talk to you about today. There's a whole bunch of obscura in the DNSSEC realm which you may want to know about. In fact, you may have some axes to grind. Well, how do you handle non-existent records like NSEC stuff? How do you tunnel trusted records to registries when the registrars? By the way, there's